Val, are you the host? Okay. All right. Hello, everyone. My name is Daisha McFall. I'm the Assistant Head of Admissions at the Institute for Advanced Analytics, where we're home to the Master of Science in Analytics program. And I wanted to welcome you to the latest installment in our Exploring Data Science webinar series. This is an opportunity for various audiences to get a peek inside what it's like to work as a data scientist. And we have one of our awesome alums, Emily Hadley from the MSA class of 2018 here with us today to talk with you all about data ethics, anti-racism, equity, and bias in data science. So I'm going to go ahead and turn it over to Emily, and I hope you enjoy.
Thank you so much for that great introduction. I'm Emily Hadley. I'm a research data scientist. I work at RTI International. We are a nonprofit headquartered in the Triangle. And I'm so excited to be here today to talk about data ethics, anti-racism, equity, and bias. This was something that I first started learning about when I was a student at the IAA, and has since become a really important part of my professional role as well. I also want to give a shout out to Jim Box, who did a really great webinar, I think in December, on bias in machine learning. So there's some topics that he covered that I definitely recommend checking out if you get a chance. And this kind of builds off of that. And we'll cover some more theoretical aspects of some of these concepts and definitions, as well as some key decisions that analysts and data scientists often make, and how you might be able to think about equity and bias and anti-racism and ethics when you're making some of those decisions. So my kind of key takeaway that I'm hoping everyone who joins this webinar gets from today is that as data scientists, analysts, creators, and consumers, we all play a role in understanding and confronting ethics, anti-racism, equity, and bias, and data and algorithms. And this is kind of a long statement, but I think it's really important in a world where so much data is being collected and being used to make decisions that impact you, that impact people that you care about, and becoming an informed citizen, but also an informed data contributor or data professional on these topics is really important towards the development of this space. So just kicking off a couple of acknowledgements and commitments as I start this webinar. As we begin a webinar centered on equity and bias and algorithms, I'd like us all to begin by acknowledging that we each bring a unique perspective and accompanying beliefs to this conversation. Sometimes conversations related to equity and bias can be quite challenging, and it's important to respect the perspectives that we each bring. And that there is a rich history of research in this space, particularly by individuals from underrepresented backgrounds and communities, and whose work should really be amplified. And that's what I'm trying to do here. I'm sharing a lot of knowledge that I've learned from other places. I try to include sources wherever possible. And I'm committing to providing an inclusive space for conversation, providing sources and additional resources for topics covered in this presentation, particularly to leaders from underrepresented communities working in this space. I stand on the shoulders of some really fantastic researchers, and there's some really, really cool things that are happening right now that I'd like to share with you, and to welcoming feedbacks and from learning from my own mistakes. I hope that by joining, you commit to joining this space to share and listen with an open mind, to participate in an inclusive space for conversation, dialogue, and reflection, and to providing feedback and being open to making and learning from mistakes. So, like I said, we're going to be doing a little bit of a dive into some key definitions related to the four concepts that I put in the title of this presentation and the landscape related to some of these concepts. But let's first start with what is an algorithm. I think one of the comparisons to algorithms that I've always loved is this idea of an algorithm as a recipe. You give it inputs, you give it ingredients, and you provide a series of steps, and then you achieve some sort of objective. So, making a recipe, put in the ingredients, you follow the steps, you might get a cake out of it. When you're building an algorithm, you put in the ingredients, which is oftentimes some sort of data or some sort of, images or something like that. You provide the steps, and then you get the output of it, which is some sort of outcome, classification, prediction, something like that. So it's a well-defined sequence of instructions or operations that a computer performs to complete some objective. And I'll mention artificial intelligence a couple of times in this presentation. It's really just an extension of algorithms to performing tasks commonly done by intelligent beings, typically humans, and can include autonomous kind of performance of this task, but doesn't necessarily have to. What am I talking about when I talk about data ethics? So ethics is an enormous space. I think I took at least 2 courses just on ethics in undergrad. And so I'm not going to be able to talk about ethics, in too much detail in a short webinar today. And you might have taken ethics courses as well and be aware that it's a very kind of very large space, lots of dialogue, but it generally focuses on systems of moral principles that govern behavior. And in particular, data ethics is focused on those systems as they relate to data and algorithms. This was a really great piece that came out of a center at Harvard. I think they put together a really nice visualization that I encourage you to check out online on what they called principled artificial intelligence. They reviewed 36 prominent AI principles documents and identified a series of key themes in it. And I'll say that these themes are by no means like the only list of themes I've seen related to data ethics, but they cover some of the big pieces of it. So international human rights, promotion of human values, professional responsibility, human control of technology, fairness and non-discrimination, transparency and explainability, safety and security, accountability, and a really, really big one that a lot of different sources are going to talk about is privacy. I won't be talking about too much about privacy today. I do think that there's a large overlap between it and data ethics, but I show this visualization for 2 reasons. First, there's a lot of different places talking about AI principles. Some of them you might have heard about before, like GDPR, which is what Europe uses to govern the use of data and algorithms. Some of them are more kind of think pieces that are coming out of private industries, but pretty much a lot of this work has happened in the last 10 years or so. And so a lot of it's really recent, and companies and organizations and countries are still trying to figure out what exactly is an ethical system for governing the use of data and the use of algorithms in practice. And so today, what I'm talking about is really the tip of the iceberg. Equity, bias, ethics, anti-racism, all really, really important pieces when we think about algorithms and how they're used and how they affect us. But there's a lot of other pieces as well: fairness, responsibility, privacy, social good, interpretability, explainability, trust. All of these pieces will show up in the literature. They'll show up in different ways, and how companies operate and what they think about and what they're concerned about. This is a 45-hour-long webinar. So I'm not going to be able to cover all of these in great detail, but I'm hoping that this is a launching point for you. So if you find an interesting piece in this presentation, dive into it, keep asking questions about it. Because like I said, there's a lot of new things coming out in this space every day, and being a part of that conversation and introducing it to others is kind of like why I do this. And I hope why you do as well. So kind of some landscape and the scope of the challenge. Why does this matter? Well, conversations about bias, ethics, equity, and anti-racism show up in all sorts of different areas. So we have lending and financial institutions, which have long been concerned about discrimination, because historically there has been discrimination in lending. And thinking about, our algorithms perpetuating that, our algorithms confronting that, kind of how are they operating in the financial space? Image searches and search engines more broadly, and this is an example from Google's image search having a sexism problem, and how images are showing up and how they might be perpetuating existing sexism that exists in society. Ageism, another really important topic, and health broadly has been a space where a lot of algorithms have popped up as well. And so seeing a lot of conversation in the health space, just because there are pretty significant implications at the individual level when your health data is being fed into an algorithm that then spits out an outcome. And if that algorithm is reflecting some sort of bias, it might impact the type of treatment or how you get treatment or medications or something like that. And another example here from criminal justice, another really important space, this wrongfully accused by an algorithm piece is about facial recognition in particular, and how facial recognition led to an arrest for somebody who was innocent. And it was based on facial recognition alone. So this challenge exists everywhere. I explicitly choose news articles because they pop up in the news as well. So if you have a particular news source you like, there's definitely a lot of conversation related to these topics in the news. And I encourage you to think about kind of algorithms that you might encounter on a day-to-day basis, and how they might be equitable or not, or biased or not, and how you might kind of consume news to inform you on some of those. Bias. So bias is a really tricky concept to kind of nail down. And I've kind of been thinking about bias a lot. And this is a source from Danks and London wrote a piece in 2017 that talks about how bias oftentimes has a negative connotation in the English language. We think of bias as being bad, something to be avoided, problematic. The way it was introduced in this particular paper, though, is kind of in what they consider an older or more neutral way. This idea that bias simply refers to deviation from a standard. And I think this is a helpful framework to look at it because bias doesn't just show up in algorithms, it shows up in a lot of different places in society. So statistical biases, cultural biases, legal biases, moral biases, and cognitive biases. And certainly there are many more biases beyond what I've mentioned here. But one thing they all kind of share in common is this idea that there's some sort of deviation from a norm, might be a population value, might be some sort of legal standard or something like that. But it isn't necessarily inherently negative. It's just kind of reflecting some sort of deviation in one direction or another. And so when we're talking about algorithmic bias, well, there's again some varying views on how to interpret this and how to define this. So I've got 3 different papers here, each with kind of 3 different perspectives on it. The first is that Danks and London piece where I got that bias definition from, and extends it to this idea that, bias in algorithms is the worry that an algorithm is not merely a neutral transformer of data or extractor of information, but that it's kind of perpetuating or projecting some sort of bias either in the data that it's using to build the algorithm or in the decisions of the people who have built the algorithm, but that it's not necessarily neutral in and of itself. The second source is from a health piece, which kind of extends this idea and does focus on those negative implications of bias and this idea that the application of an algorithm compounds existing inequities. So those could be inequities related to socioeconomic status, race, ethnic background, religion, gender, disability, sexual orientation. And not only does it compound it, it amplifies them and can adversely impact inequities in healthcare systems. So we're talking about algorithmic bias where we are talking about something negative, particularly in this second example. And then the third example, I think, is a narrow view that I oftentimes see come up in this space, and it's really a focus on model performance, and this idea that algorithmic bias is when the model performs substantially better or worse across mutually exclusive groups. So, you could compare different genders with each other, different races, and see how well does the model perform on each of them. And that's a really important step. I think that's we'll talk about that. It is really valuable to calculate those metrics and do that comparison of model performance. But I think that just focusing on model performance is too narrow. There's a lot of different ways that bias can enter a system of algorithms and data, and model performance is a piece of it, but not necessarily the entire story. One important attribute of algorithmic bias to consider, and this is, I think, a lot of times the first introduction individuals working in this space might have to bias, is related to anti-discrimination. So in the US, we have a series of anti-discrimination laws. They prevent you from being discriminated against based on a series of protected attributes in specific instances in your daily life. So you can't be discriminated against in voting, public education, employment, public accommodations, and lending, and there are others as well. And you can't be discriminated against for these protected attributes. And it's worth noting that not all of these protected attributes apply in all of these scenarios, but some of the common protected attributes are race, color, religion, sex, sexual orientation, national origin, age, disability, pregnancy status, family size, and genetic information. And the reason I bring this up is, you can't be discriminated against by a person in these situations, but in many of these, you also can't be discriminated against by an algorithm. So there is strong kind of legal backing for how bias shows up in algorithms in these specific cases. So to give an example of this question of what is legal as it relates to algorithmic bias, well, it is not legal to have an algorithm that is biased on the basis of age as it relates to employment. So this particular example came from Facebook. Facebook was allowing employers to only show ads to people of particular age brackets. In this case, allowing employers to only show ads to people under the age of 40. And people over the age of 40 might not ever know that they weren't even seeing those ads because they had no way to discover that piece of information. And this is illegal under the Federal Age Discrimination and Employment Act, which protects people ages 40 and older from discrimination and employment. So this was a lawsuit that went forward. I believe it was a class action lawsuit. Facebook did settle and no longer allows for micro-targeting on the basis of age. However, that's, it's a narrow setting. It's employment, it's age, it falls under a particular legal law. And there are certainly plenty of algorithms that exist that allow for something similar that's not illegal. So this is an example with dating apps. Wired did a kind of a investigation into different dating apps. You may have used one yourself at some point. Dating apps frequently collect race or ethnicity. Some of them allow for users to state a preferred ethnicity in a potential partner. And it looked like a majority of the apps they looked at also allowed users to filter by race or ethnicity. Now, I'm not necessarily commenting on if this is bad or good, but what I am saying is that this is not illegal. This is perfectly within the legal bounds of how dating apps work. And so we do have legal forms of discrimination and bias in algorithms on the basis of protected classes. And it's important to know about that because, you know, sometimes I've had people come up and say, well, can't you just like sue a company for bias or discrimination on these protected attributes? And it really depends on the law, and it really depends on kind of that narrow framework. So when we're talking about bias in algorithms, sometimes it's illegal, but generally it's not. So taking that kind of discussion of legality and bias and extending it to the idea of equity. One of my favorite legal pieces related to discrimination in algorithms is this one I've cited here, Discrimination in the Age of Algorithms, written by a couple of lawyers. And one of the really big pieces of this paper are, you know, we've talked about some concerns related to algorithms being a threat, which they certainly can be particularly when they're not regulated. But this particular paper points out that with the right safeguards, algorithms actually have a potential to be a positive force for equity. What do I mean when I talk about equity? This also falls under it's very hard to define. People have been talking about it for millennia. There's not necessarily a single consensus view on what equity is, but oftentimes when people are talking about equity, they're talking about fairness and quality of both the decision-making process, in legal terms, if there's procedural equity, as well as the quality of the outcomes of the decision-making, otherwise known as outcome equity. Equity can look really different by context. It can also be really deeply contested. I appreciated the point though that this paper made that most people in modern American life have really strong beliefs about the nature of equity in social institutions, even if these beliefs are incomplete or not explicitly spelled out. And this shows up, for me at least, a lot in the algorithms and data space, because when I'm talking with stakeholders, particularly people who are going to be impacted by the algorithms we're working on, they do have very much of a sense of like what is fair in the algorithm we're developing and what is not fair. So paying attention to equity, noting that it's going to be complicated, it might be different depending on who you're talking to. And I think it's important to think about, you know, kind of what your perspective is on equity. So I'm going to share mine. You might have seen this type of figure before. It's a comparison between the ideas of equity, equality, and justice. And it's a figure that shows 3 children attempting to watch a baseball game. The green grass hill they're meant on is meant to reflect kind of this challenges that they've experienced. And under equality, you know, we gave each child in this figure the same size box to kind of see this baseball game, but it doesn't reflect that they've faced different challenges in their life experiences. And so, you know, some of those might be systemic, some of those might be historical in different ways. And the equity figure, the second from the left, reflects the idea that, you know, maybe we need to make adjustments and not give everyone the same box, but actually make adjustments to kind of where they are coming from and the perspectives and the backgrounds they have. I really like this particular figure. It's put together by the Interaction Institute for Social Change because it extends the idea both to justice, this idea of like, what would it look like if we actually just tore the fence down? And an idea of the fourth box, like what would be in your fourth box in a more equitable world? And so I pulled out this quote here. I think I align more closely with kind of an egalitarian idea of egalitarians will seek to use algorithms to identify where historical inequities produce unfair outcomes and leverage the power of algorithms to correct for these results. So it goes back to the idea that like algorithms are not neutral. They reflect the biases in the data that's used to build them. They reflect the biases in the people that build them, and that we can make decisions to make algorithms more equitable and lead to more equitable outcomes. Anti-racism was included in the title of this talk. I think it's a really important framework that I use when I'm looking at algorithms and making decisions related to my work. I really like this Angela Davis quote: "In a racist society, it is not enough to be non-racist, we must be anti-racist." And I think particularly when you're working on algorithms that were related to individual decisions, so decisions that will affect individual people, it's really important to think about how race might be playing into the algorithm that you're working on. We have examples of historical inequities and discrimination in the US in particular that's related to race. And so I'll mention later how some of those can lead to correlations and models that you're building that can affect your outcomes. This Ibram Kendi quote from the book How to Be an Anti-Racist notes that an anti-racist is one who endorses the idea of racial equality, locates the roots of problems in power and politics, and confronts racial inequities. And I think that that's a framework that you can bring to your work as a data analyst or data scientist or statistician, or just a data professional, and think about what is showing up in the data that I'm using, how does it relate to individuals, and how does it in particular relate to race, and ideas of kind of systemic discrimination and historical discrimination, and how could I, as a practitioner, make decisions to account for that and address that as we move forward. We're getting towards the end of the kind of the pieces related to kind of these conceptual frameworks. I do want to mention some statistical concepts of equity. I've used a lot of words and a lot of language, and so here you're seeing some mathematical formulations. I'm not going to dive too deeply into kind of the math equations here, but I have noted the definitions of these kind of 4 key concepts on the right. And these are kind of statistical concepts of equity that we see show up pretty often. The first one is this idea of fairness through unawareness. It's the exclusion of sensitive attributes as inputs into a decision algorithm. So this idea that, if you don't have race as a variable in your model, the model can't be biased on the basis of race. And this pops up a lot in that anti-discrimination legal literature I mentioned. I think it's really, really popular in the legal space to say, well, if we didn't include race, this definitely can't be biased on the basis of race. That has been challenged multiple times, where just because you don't have that protected class in the model doesn't mean that there's not something else in it that is correlated with that protected attribute, which can oftentimes still lead to biased outcomes. The second principle or concept is individual fairness, the idea that assignment of similar outcomes should happen to individuals with similar attributes. The third is demographic parity. Distribution of positive or desirable outcomes mirrors the general population class distribution. And then finally, equal opportunity, which is that there should be equal true positive or rates of desirable outcomes across classes. We often see that demographic parity and equal opportunity are in conflict with each other, because it's generally not the case that an equal true positive rate across classes mirrors the general population class distribution. So I mentioned these, noting that you can't really optimize all 4 at once. You have to make decisions on which concepts of equity you're using and how you're using them. And I'll mention some of the actual mathematical calculations we do to measure some of these in a couple of minutes, but pointing out that there are choices and priorities to be made, and there are a lot of different ways to define equity, both in words and in math equations as well. So the last slide in this section, who plays a role in this? Everyone. And really, I'm serious about that, because I do think that, I've mentioned a lot of different categories of people on this slide, of people who interact with algorithms in an ethics, equity, anti-racism, and bias space. That includes everyone here today as individuals. We live in a society and we interact with algorithms, and we should definitely care about this because it impacts us, it impacts people we know, it impacts our future. And I think we'll only see more rather than less of this type of use of algorithms and data. You may be attending this presentation today because you're interested in becoming some sort of developer or data scientist or analyst, and you may find yourself making really key decisions when building algorithms. We'll talk about some of those key decisions next, but noting that you as a person can make a difference in how these algorithms are deployed in practice. That being said, there's a lot of other institutions that can make a difference and may have some of the more long-standing differences as well. So I'll highlight governance boards, institutions, and governments in particular. I think that they have a lot of leverage in this space to help guide regulation. And I do think that regulation is ultimately what's going to lead to a more coherent understanding of some of these concepts in practice. And of course, we're at an education institution right now. So I would be remiss if I didn't highlight that educators are so important to sharing this work and sharing this knowledge with all of the people who are going to continue to play roles in these entities mentioned on this slide. So our next phase, kind of the next big portion of this presentation, is on decisions and approaches. And when I design talks like this, really, one thing I like to think about is what would I like to take away as a practitioner that would help me kind of improve my day-to-day workflow. And I mentioned this workflow because I think there's there's similarities in a lot of the projects that I do. So a lot of them have kind of three key phases. They have the planning phase where we're determining what we're going to do during the project. We have the implementation phase, which is where we actually put the model into practice or develop the application or whatever it is that we're working on. And then we have the interpretation phase. And so maybe that's where I'm interpreting the results. Maybe I'm developing some sort of visualization or tool to share the results with others. But oftentimes they're kind of these three key phases. And within each phases, there's a lot of decisions that you make. And I've identified some decisions, particularly in my own work, that I found have an opportunity to address bias, equity, or ethics in some shape or form. I've got a much longer version of this presentation where I go into all of the topics and go into them in pretty substantial detail. We don't have time for that today, so I've really focused on just a couple of the items here. And so there's about 2 in each section that I will cover. But yes, apologies for not being able to cover everything today. The one really key idea I hope that folks were able to take away from this is that there's no single tool or approach that makes a project unbiased, anti-racist, and or equitable. Rather, it is a commitment to recognizing opportunities for bias in a series of key decisions and acting to address these challenges when possible. The piece that I'm really trying to highlight here is I think that there's a tendency to just look at model performance metrics, for example, and say, oh, I'm not seeing any bias in model performance metrics, everything must be good. I don't think that's the case, though. I don't think that there's one approach that'll solve everything. It really is a holistic approach and requires kind of a more complex view of the many decisions that go into this work. So looking at that planning phase, planning phases kick off with determining a motivation or research questions, and the determination of motivation or research question will really shape the decision-making and prioritization throughout a project. So this hypothetical example I give here, you are designing a healthcare deep learning tool for diagnosing diseases by looking at images. What are some possible motivations or research questions? And, coming from a data science perspective, I think oftentimes the idea that comes to mind is, how accurate can I make this? Can I make this really good so that it's useful because we know that it's really accurate? But I'm going to challenge that motivation with this example here. So this came out of Google Health. Google Health created a deep learning system that looked at the images of the eye for diabetic retinopathy, which is a leading cause of vision loss around the world. They were able to develop a model that had really high theoretical accuracy. However, the tool was also very impractical in real world testing, and it was very frustrating to both patients and nurses with inconsistent results and a lack of harmony with on-the-ground practices. There's a quote from a nurse here: "Patients are not concerned with accuracy, but how the experience will be. Will it waste my time? Does it take more time? Should I go somewhere else?" And I think it's this type of view that's really, really important when you're first designing the project. Like, yes, accuracy is really helpful, but for having a real world impact, it looks like there needed to be more conversation with the stakeholders on the ground of how this tool was actually going to be used. So when you're designing your research project and you're developing your research project, this is a form of equity and bias because there's particular individuals that were not necessarily included in the conversations related to the motivation and the research questions for this project. So I think that, when we're putting research projects together, incorporating perspectives from individuals with lived experiences in these spaces, as well as trying to figure out whose perspectives we might not have included, can be really helpful to making sure that the research that we're doing aligns with the needs of the communities that we're trying to serve. Data collection. Another really important piece of the planning process, a really complex topic. I'm pretty sure you can take entire courses on data collection and as it relates to bias and equity and ethics. There's a lot of different ways to collect data, a lot of different types of data to collect. Could be surveys, could be existing databases. You might be scraping data from the web. You could be getting data from surveillance cameras or social media or location. And there's a lot of conversation to be had around ethics related to collection, storage, and rights related to data. The two pieces I really want to mention here that I think are important decisions or things to reflect on are, first, the representativeness of your data. This is another healthcare example. There was a group that reviewed over 70 publications related to medical AI, and they found that the majority of these publications the algorithms were trained on data that came from just 3 states: California, New York, and Massachusetts. And they dive into some deeper concerns related to diversity of this data by race, gender, or geography. But really the point, and you might have seen this pop up in other areas, is if you train your model and the underlying training data set is not diverse or not reflective of the population you're looking to apply it to, it's a really large opportunity for bias to enter your data system. So as you're planning your process for collecting your data and where you're going to get your data from, thinking about the representativeness is really important. Another piece, this is more closely related to privacy. I think this just is a really interesting case that I didn't hear about until just recently, but back in 2007, when Google was first developing Street View, which you might notice in Google Maps, they would send cars out into neighborhoods to photograph them for Street View, but they were actually also gathering emails, passwords, and other private information from Wi-Fi networks. The company initially called this a mistake, but it was actually something that was intentional on the part of engineers. And so this is a really important story about consent and violating people's consent to collect this information, because again, these are just cars driving by people's houses. And I think that as we talk about trust in algorithms and as we talk about equity and bias, the way that the data is collected could be discriminatory in one shape or another, or lead to bias against particular communities. So as you're doing your planning and thinking about where the data is coming from, asking these questions about consent are really, really important as well. One way to think about this is if you work for an academic institution or you work for a research institution like RTI, there's a good chance that you'll have to report to an IRB. This is an institutional review board. This is a board of ethics and independent personnel that review research before it occurs. Particularly, it's meant for research with human subjects. And it's meant to protect the right and welfare of human subjects because of a history of honestly abusive human subjects research, including in the United States. And so IRB is meant to kind of combat that and prevent some of these bad experiments from happening. And I really have seen more recently, probably in the last 2 years or so, an increased call for similar approach to algorithms in practice in academic and private and public sectors. And this is an idea of like an algorithm review board or an ARB or an ethics AI committee or something similar that really kind of considers some of those questions related to data collection and modeling and the research and the motivation. And they do this before the algorithm is even developed or put into practice. So if you're in a place where you're thinking like, how could we think more about the algorithms that we're building before we put them into practice, an algorithm review board could be a really neat and interesting approach. So that second phase, we're going to talk about implementation. We're going to talk about two pieces of it. The first is calculating summary statistics. I think summary statistics are something I often do during exploratory data analysis after I've gotten a new data set and I'm asking questions like, what trends or patterns am I seeing in this data set? What's the mean, the minimum, the maximum? Am I seeing outliers? Like, what can I learn about this data set? And oftentimes I'm disaggregating the data by different attributes to kind of understand, how are different variables related to one another. Considering what attributes I've often used for summary statistics, some of these might be protected classes like race, ethnicity, gender, and place of origin. But we get into a really complicated space as well when we talk about what these attributes actually mean. So this is an example of the US Census question that asked about ethnicity and then it asked about race and allows for selection of multiple race groups. Many people find this US Census question really hard to answer. You might be one of them for a variety of reasons. Some of those might be a mismatch between perceived and self-identity. So the way you identify might be different than how you're perceived in society. And from a statistical perspective, this matters because we're saying, a whole group of people share a similar experience because of the results that they've selected, but that might not necessarily be true. And this kind of idea extends to some concerns around large groupings of individuals, regardless of geographic association or nationality identification. The Asian category in particular gets a lot of criticism for this. Somebody who's Southeast Asian might identify differently from somebody who's from Eastern Asia, or even more so related to nationality identification or geography. And again, it's that concern that, when we're saying that all individuals who check this box share a similar experience, that may not necessarily be the case. Unclear categorization. Criticism is often related to folks who are identified as Middle Eastern here, who don't necessarily feel like their experiences are reflected in the options that they get to choose from. And then finally, this idea of loss of information when two or more entries are grouped together. So, what is a multiracial category saying? Are people who select two or more races all sharing the same experience simply because they selected multiple boxes? I think that there's some really valid criticism of, what does it mean when we calculate summary statistics by race or ethnicity? One side note here, these classifications are very US specific. If you're doing research outside of the United States, it's really important to know that race and ethnicity have really different definitions and categorizations in non-US contexts. To dive even a little bit deeper into this, I think that the definitions of the categories themselves can be a little bit suspect. So the Hispanic and Latino ethnicity categorization is actually a categorization that was developed by the US government. It was first introduced, Hispanic was first introduced in the 1980 census, Latino was first used in the 2000 census. We've seen a rise in the use of the term Latinx, which is a more gender neutral term following the 2016 shooting at the Pulse nightclub. But the larger idea here is that there's not necessarily, there was no group of people who came together and said, we should call ourselves Hispanic or Latino. Instead, it was a definition that was created kind of at a top level and projected down onto a group of people who may not share a similar experience or a similar identity. And so when you're making some of these summary statistics, again, thinking about what am I saying, whose experiences am I grouping together? Do they actually share the same experience? And oftentimes when we're doing a summary with race or ethnicity in particular, what we're trying to get at is this idea of marginalization. We're trying to get at this idea that people have different experiences in their day-to-day life. And so I went to a workshop put on by an organization called We All Count. Really enjoyed it. I really loved this idea that they shared of using a perceived marginalization scale to capture, ideas related to, this is an example they gave, noting that there are other perceived marginalization scales in literature, but things like in your day-to-day life, how often are you treated with less courtesy than other people are? You receive poorer service than other people. People act as if they are afraid of you. People act as if they think you are dishonest. You are called names or insulted. And you can follow that up with a question on, what do you think is a reason for these experiences, or multiple reasons? It could be your ancestry, your gender, your race, your age, your religion, physical appearance, or many others on this list. And I think that this better gets at, kind of if you're trying to ask about marginalization, rather than use race and ethnicity as a proxy for it, you should really just ask about it itself. So if you're in a planning phase or in a data collection phase, and you can ask these questions more directly, I think it can lead to better summary statistics to get at the real question that you're asking. The other piece I'm going to talk about related to implementation is modeling. So modeling, the act of combining data and mathematics to approximate a system and use for analysis or prediction. This receives a great deal of focus, and as it should, because a substantial number of decisions occur during this portion of the analysis. The three pieces I'm going to talk about related to modeling are correlations between variables, explainable model options, and metrics for evaluating model output. So correlation, this is a big one. This study down here is a really important study because it showed up in Nature and it illustrated that there was an algorithm that's being used in practice in healthcare systems, and that millions of Black people were affected by racial bias in this particular algorithm. The reason that this happened was that the developers of the algorithm considered their algorithm to be race blind because they did not include race as a variable in the algorithm. However, they didn't account for the fact that they used another variable, projected cost, which did have a relationship with race. And so at the end of the day, what happened was that the outcomes of this particular algorithm were different by race and were leading to different healthcare outcomes for individuals. So the big takeaway from this particular example is that fairness through unawareness, one of those equity items we mentioned earlier, is not a sufficient condition to address discrimination. Just because you don't have a protected attribute in your model does not mean that your model will not lead to outcomes that are biased on the basis of some sort of protected class. And so I think that this is a really, really important idea to bring up. And sometimes I've seen examples where including the protected class actually makes your algorithm less biased. Now that leads to a larger conversation as well, related to like causality and what you're saying when you're actually including that variable in the model. But I think it's really important to know that just because you don't include that protected class in the model doesn't mean you will have a unbiased algorithm. The next piece to mention, explainability. So this is the idea that, models can be really complicated. And there's a growing interest in the idea of explainable AI, which is often abbreviated XAI. And I've shown this in this kind of plot of Google trends for what people are searching on and interested in. And there's a lot of debate on what explainability is and what it means for an algorithm to be explainable. But I think that the big takeaway here is that oftentimes stakeholders care about how the model made its decision. And it's not great practice to just say, I don't know how the model made its decision. I think it's important to know, depending on the cost of making an error. If you've got a really high cost of making an error, like if you make an error, somebody is going to go to jail, or if you make an error, somebody might not get treatment. That's a very, very costly error. And so you want to know how that model is working. I think there are strong arguments to be made to really consider transparent models in that example. This is a really great tree that Barreto et al. Did of a kind of meta literature review of explainable AI and machine learning. The transparent models are kind of that first branch off. Those are things like logistic linear regression, decision trees, k-nearest neighbors, GAMs, Bayesian models. I think a lot of those are really great models to consider, particularly when you explicitly need some level of explainability and interpretability, and especially in those high cost situations. But in other situations as well, I think there's so much work coming out in the XAI space that it's not sufficient to say, oh, this is a black box model, I don't know how it works. There's a whole bunch of examples here. This tree actually goes like way down onto 2 pages, and there's a lot of options to better explain models that were previously described as unexplainable. Are they perfect explanations? No, some of them are more well-developed than others. But I do think we're entering a space where it's really important to think about explainability and explainability to stakeholders, rather than just kind of saying, not explainable, let's keep moving forward. Modeling metrics. This was a slide I showed previously, kind of those statistical concepts of equity from a mathematical perspective. These can be further separated into a number of different calculations. I show this decision tree, or not really a decision tree, it's a fairness tree that was developed by a group called Equitas. This is available online, and it can help you do your own calculations of metrics related to fairness and bias. There are a lot of metrics, and I don't think that the space has really kind of honed in on exactly which ones are always appropriate or not appropriate. And I think that there are still ones that are kind of being designed and developed. Google has a really great machine learning fairness glossary, which can be a good introduction to a number of those definitions. Some of them are showing up here: equal parity, proportional parity, false discovery rate parity, false positive rate parity. So you can see there's a lot of different options. Choosing which metrics you're going to use, I think, is a really important part of the project and takes longer than I anticipate generally, just because there's a lot of conversation around, what are we prioritizing? Are we prioritizing false negatives, false positives? Like, what are we trying to minimize? And having that conversation is a conversation that shouldn't just happen with data scientists, but also should happen with the stakeholders and the individuals who will be affected by the work that you're doing. And the last piece I'm going to describe here is this interpretation piece. So, you've done the planning, you've created the model, and now it's time to share it with the world. The first piece that I'm often asked to do is I'm often asked to interpret model output, and I'm often asked to translate it for less or non-technical stakeholders. And so some things that I consider, will somebody be reviewing my work? Is there some sort of quality assurance program? And is there opportunity for me to make an error similar to this? So this is called Simpson's paradox. You might be familiar with it. It oftentimes pops up in statistics classes. This is a scenario where departments at a college are looking at their admissions and rejections between 2 different racial groups. And if you look at the blue box here, you'll see that the overall admissions rate for racial group 2 is higher than for racial group 1. But if you were disaggregate by department, you'll actually see that the admissions rate for racial group 1 is higher than for racial group 2 in every category. So if neither one is wrong. If I ask the question, which admissions rate is higher, the answer for the total of everyone is going to be different than for the departments. But the information will be important to stakeholders. And so when you're kind of presenting these results to stakeholders, asking questions like, am I missing a trend that would be visible with disaggregated results? And I think in particular, asking your stakeholders if there are disaggregations that you're missing, because I think sometimes the stakeholders who are subject matter experts will have a better understanding of what disaggregations are needed as compared to the data analysts or the data scientists who might be less familiar. And then finally, visualizing results. I'm oftentimes asked to make visualizations. I think a lot of data analysts and data scientists are, because they're a really great way to communicate with non-technical stakeholders. However, just because you're asked, if you haven't necessarily taken training in the space, there's a lot that you can learn related to bias and equity. The tool that I generally recommend people check out is the Do No Harm Guide, which just came out from Urban Institute last year. They do a really great job of kind of considering different accessibility guidelines, like, for example, having sufficient contrast between colors, which will help readers with vision difficulties, and also commentary related to things like color choices, which should avoid reinforcing gender or racial stereotypes. So I kind of cringe whenever I see a visualization that uses baby pink and baby blue to represent women and men. And certainly when I see, colors with skin tones or racial stereotypes to represent different racial or ethnic groups in a visualization as well. So the way you communicate things is kind of that last mile. If you've worked so hard in the planning and the modeling, but you don't quite capture equity and bias in your visualizations, it's unfortunate to not be able to kind of carry that impact through to the finish. So a couple of closeout slides, and then I'll open it up for questions. Feel free to add any questions in the chat. There's a lot of really terrific individuals working in this space. Joy Blum-Winnie on the far left has a great documentary called Coded Bias on Netflix that I recommend folks check out if you're interested in learning more. Kelsey Campbell is also an IAA grad on the second from the left. She's the founder of Data Science. Super cool, really neat website, great to check out. And then Safia Noble, who's fourth from the left, recently won a MacArthur Award for her work on search engines and bias in search engines. And so follow up some really great books to read. Safia Noble's book is on the far left, Algorithms of Oppression. Definitely recommend that. Really changed my views on search engines. But if you're just getting into the space and learning more, I actually recommend the book on the far right, Weapons of Mass Destruction. I think it's a really good introduction to this space and has a number of interesting case studies. Some really great organizations to support, doing really important work in the space. I'll highlight We All Count, which is on the far right. They do equity-related trainings related to data science, and they also have a lot of great resources on their website that are worth checking out. And finally, some acknowledgements. Thanks to RTI International and the Center for Data Science for supporting my growth in this space. I've actually funded under a professional development award right now, which is a really neat thing that RTI offers to allow employees to kind of dive deep into research topics that they're interested in. And this is mine. Some presentation reviewers, Rob and Megan, who I both work with at RTI, and a number of individuals and organizations who have contributed to my journey and growth. All right, so that is my final slide in the presentation. I apologize for talking a little bit fast there towards the end, but I do want folks to be able to have time to ask questions if they have any.
Wonderful, Emily. We'd now like to open it up for you all to ask any questions you have. Feel free to use the raise hand feature and we'll call on you, or you can share your questions in the chat and I'll share those with Emily. Do we have any questions? Angelica.
I raised my hand. So Emily, just can you give some insights about what can data scientists do once they find out that their data does have bias in it, how to communicate that to the stakeholder and how that may impact data collection to continue using that model and things of that nature?
Totally. That is a great question. It definitely depends on kind of what part of the process you're uncovering that bias. So I think if it's in that early phase where you're still doing data collection and you have the opportunity to collect more data or collect more data from particular groups that you feel like are not represented in your data, that's awesome. That's a really great place to start, particularly if your client is kind of on board with collecting more data and funding that, because data collection is not necessarily cheap or easy. So I would say the earlier in the process that you can uncover it, the better. If you can't collect new data, I think it's always worth asking the conversation of should we proceed? Should we move forward? And I've been on projects where we've decided not to move forward because we just don't think this is going to be representative. We have too few cases. And I think that is a really key conversation to have where it's we don't think that the results of this would be valuable. I think similarly, that conversation is really important to come up when you're doing that kind of analysis of the model with various metrics. So if you see that the model is really biased, then you can kind of take that next step of being like, well, where is this coming from? Is it coming from the training data? Can we improve that? Is it coming from the way that we tuned the model, or the selection of which model we're using? Can we change that? And if those things are not improving your model output, again, having that really frank conversation of, should we deploy this model? Should we share it in practice? And what are the costs going to be of if we put it out there? So I'll share that we do at RTI. I'm working on an algorithm in the criminal justice space that we analyze on the basis of race. We didn't design this algorithm. We're analyzing it for a number of different police jurisdictions, and we do sometimes say we're like, this is too biased. Like, we don't think that you should be using this in practice. And I think having the support of your team, and then having the data that you can point to and say, this is why we think it's too biased to use in practice, is really, really helpful for those conversations.
Thanks, Emily. And just a quick follow-up question, since I have some of my students here. They're going to do their own capstone projects coming up, and a lot of them want to do image classification when it comes to human images. And so can you talk a little bit about some potential bias that may come into these image classification models, especially with neural nets and things of that nature, and what they should look out for?
For sure. So that's a great question. I would say, it starts with that motivation. What are you trying to predict and why? And a related conversation of what is the cost of making a bad prediction. So I think if you're predicting, like, what face, predicting a particular individual based on their face, and it's going to lead to somebody being arrested, that's a pretty high cost of an algorithm. It needs to either be really accurate, or maybe it shouldn't be used at all for that purpose. So thinking about the motivation, thinking about that. And then the second piece is, so now you've, decided you're moving forward with what you're developing. Facial recognition and image training on humans has historically not been a particularly representative training set. I think it was a New York Times piece that came out and said, like 85% of the initial image data sets that were provided for training on people were, I think, white individuals. And that's not what the proportion of people who are white in society. And so as you're choosing your training data, really paying attention to what is the breakdown by race, what is the breakdown by gender, what is the breakdown by age, what is the breakdown by disability. Twitter recently got a lot of criticism for an image cropping algorithm that was not only cropping out individuals of color, but it also cropped out individuals in hijabs, and it also cropped out individuals in wheelchairs. And so I think paying attention to not just, paying attention to the many ways in which bias can crop up in your image training data set. Then moving on to the modeling itself, thinking about, as you're working with neural nets, they are challenging to explain, but it's not sufficient to just say, oh, I can't explain this at all. There are some really interesting techniques that have come up with neural nets as it relates to images that will, for example, show you why the image is making its decision. So it'll highlight the features of the image that have led it to put it in a particular category. So when it's categorizing like dog versus horse, it might highlight the parts of the image that are more clearly dog than horse to help show you why it made its decision. I'm not exactly sure if you're doing a classification approach, but trying to think about, is there a way that I can apply some of these explainability methods to my images to figure out how the model made its decision, even if I can't really understand the algorithms and the math underlying it. And then that last piece related to what the images are doing in practice. I think communicating with stakeholders is a big one here. So the ACLU has released some really interesting toolkits on criminal justice and algorithms. And a big piece focuses on, how are these being used in practice? And facial recognition is a big one. And so if you're thinking about doing that work, doing some sort of project related to the criminal justice space, I think looking into some of that literature on how that work is communicated, at what point a jurisdiction chooses not to use a image recognition program or to use one, I think can be a really important piece kind of related to that initial motivation question as well. Is that helpful? Great, thank you. Well, good luck with that project. That sounds fantastic.
Oh, I'm not doing it. But anybody else that's doing it, good luck, students. And I think we have some questions in the chat, and one of my students has their hand raised.
So before we get to the hand raise, I do have a couple of questions that popped up in the chat. So Felicity wants to know, what was the most surprising bias in a data set or algorithm you found in your work so far?
Ooh, this is a good one. This actually just happened the other day. So I'm working on some like text NLP prediction related to college majors. And we have found, and essentially we get the text for what a student's college major is, and then the algorithm predicts what larger category it belongs to. And the algorithm was based off of BERT, which is a larger NLP algorithm developed by Google. And we're seeing an interesting correlation where majors reported by students as like cannabis or herbal studies or cannabis and herbal studies have popped up. The most common category we get suggested for it is related to Islamic studies. And that was a surprise for us, and not something like, I don't know, I can't find evidence of a direct connection of why cannabis should be popping up as having Islamic studies as the top response. We think it's based on something in the BERT modeling algorithm. We haven't really been able to investigate it too much so far, but like one of the features that we do in that response is this is a recommendation system for people who label surveys of higher education data. And so we've forced that to not be a connection because, I don't know, that seems offensive to me. So.
Thank you. Okay, so I do have a question about the slides. Emily has agreed to share the slides for this presentation, so we will make sure to send that out to everyone who is registered. Now we'll take a question from Eileen.
Hi, it's nice to meet everyone. Jelly spoke very highly of you guys. And I think this is exactly the presentation I needed to hear relating to my capstone. I was gonna do a project on incarceration rates, and of course there might be some bias in there. And Jelly told me to present it in a way where it's bringing awareness and not sort of answering a question or a business problem. I was wondering if you had any advice on how to approach it, if you had any more advice for me.
Totally. That is great. Well, I'm so excited to hear from you. Thank you for asking that question. And that is such an important topic. So I'll share that. I mentioned that I work on criminal justice algorithms. One of the things we struggle with a lot is that the base rates of arrest are very, very different. So we work with a couple of different jurisdictions, and we often see that individuals of color are arrested at far higher rates than white individuals. We can't do anything about that though. Like, our algorithm begins from the moment they're arrested and then ends at the moment that they are prosecuted. And that is a space where we're like, well, we're not making the bias any worse, but it's really important that you know that there was a lot of bias to begin with, and we aren't solving for that at all. And so I think that, just highlighting that in a way where, like, well, it's interesting because a lot of the stakeholders that we work with who are criminal justice stakeholders don't know about this. They don't necessarily know that their own data is saying, you are arresting individuals of color 3 times as often as white people. And just because somebody's arrested doesn't mean they're guilty. Like, that's the big challenge, is that you're innocent, you're in theory innocent until proven guilty in the US, but that doesn't mean that a judge isn't going to hold you in jail until your first trial or until your first appearance, so that you can figure out if you're actually going to be charged with something. So those arrest rates are really, really important for places to know, because when somebody's arrested and then they're held in jail, they might lose a job, or they might lose custody of their children, or they might have some other life-altering event happen, and they might be totally innocent and they might not ever be charged with anything. But the US has a really, really big problem with very large pretrial populations. And that's fueled both by risk-averse judges and magistrates who don't want to be responsible for somebody, going on to commit another crime because they didn't hold them in jail after they were arrested. And it unfortunately is also somewhat because of the value of essentially, like, jails are paid money. And when they held people in pretrial, they earn money for people being in pretrial. So I think that anything you can do to illuminate some of those challenges and illuminate some of those discrepancies is really helpful, particularly communicating it to people who would care about it. And I think that we're seeing more and more stakeholders who are really interested in how algorithms are being used in criminal justice. And I think that idea of base rates is so important, because they're oftentimes also being derived from different levels of surveillance of communities. There's different arrest rates, not necessarily not because there are different levels of crime between race or genders, but because there's different surveillance rates as well. So I don't know if those were necessarily like pieces of advice for what you should do, but I do think it's a great idea, and I do think that it would be an important data kind of item, both for the individuals involved in the system, but also for people who are not.
Wonderful. Thank you, Eileen, and thank you to Emily. We are unfortunately out of time for today's presentation. If you would like to engage with this content further, I encourage you to reach out to Emily on LinkedIn. You can engage with this recording once we post it on our YouTube channel. And so we just want to thank everybody for joining us today. Hope you have a wonderful afternoon. Thanks again to Emily. And I'm going to wrap up this session.
Thanks for coming, everyone.